Okay, what we're going to talk about today is something called average rate of change. And when you were thinking about average rate of change, you essentially should be thinking about slope. So for instance, let's say I have some function f of x. The average rate of change on the interval a to b will be f of b minus f of a all over b minus a. Now what that's having you do is take the two x values, plug them into the function to find the y values, subtract the y values, and divide that by subtracting the x values. This essentially is the same as this formula. It looks a little bit different, but ultimately it's the same thing. The difference is, rather than giving you 2 points where we give you, 3, 4, and 7, 2, and say find the slope between the 2 points, we are taking these points from a function. So I have a few examples here for you. It says find the average rate of change of the function on the given interval. So my first function here is x squared plus 2x plus 1. And my interval is -2, 3. So what I want to do is find the y value for those 2 points. And I think that's easier to do first. So if I plug in -2, it is, what is that? 4 minus 4 plus 1. So I get a y value of 1. And if I plug in 3, I get 9 plus 6 plus 1, which is 16. So now I want to find the average rate of change for that interval, which means find the slope between those 2 points. So we will do y minus y over x minus x. Notice that minus the negative changes to plus. 16 minus 1 is 15. 3 plus 2 is 5. And we end up with 3. So if you have a function, you can plug in the x values, find the y values, and then compute the slope. So on the second one, I am giving you the picture of a graph. It's an absolute value function, and I want the average rate of change on the interval from -2, which would be this point here, to the point on the function at 1, which would be that point here. So now you could write down the point. What is that? -2, -1. And write down this point, which is 1, -2. And you could calculate the slope that way. However, because you have a picture of it and they both happen at nice integral values, just count it. So it's down 1, right 3. And then you're done. So you can do the slope formula, but you just don't need to because you have a picture of the graph. On number 3, we have the function 2x plus 3. Hopefully you recognize that this is a linear function. And so we are calculating the slope on the interval -1 to 5. So if I plug in -1, -2 plus 3 is 1. If I plug in 5, 2 times 5 is 10 plus 3 is 13. And then I want to find the slope. So the average rate of change is 13 minus 1 over 5 plus 1. 13 minus 1 is 12. 5 plus 1 is 6. 2. Now think about that for a second. I just got the slope between 2 points on this function to be 2. That should completely make sense. And now that you're looking at this and you're thinking about this, you should think, well, we wouldn't even have to do the slope formula. Because if you take any 2 points from a line, no matter which 2 points you choose, the slope is going to be the slope of that line. So we say that the slope of a line is constant. And what that means is it's the same no matter which 2 points you choose. The slope of any 2 points from a quadratic won't be constant. It's going to be changed. So we say the average rate of change is changing throughout the function. Whereas for a linear function, it is constant. Now, when I talk about graphing absolute value functions, the left-hand and the right-hand side of the function, the average, because they're parts of linears, each side has the same average rate of change if you're only looking at half of it at once. But if you select a point from one side and the other side, then the average rate of change is going to be changing. For the last one, the interval is not written there. I want the average rate of change on the interval -3 to -1. So the points at -3 and the point at -1 are on a horizontal line. The slope of every horizontal line is 0. So therefore, the average rate of change between those 2 points will be 0. All right, make sure you also have watched the video overriding the equation of an absolute value function, and I hope you have a nice day.